All right, guys, my name is Tom Henney. I'm the owner of Vince Pacific Enterprises here in Bennington, Nebraska. Vince Pacific Enterprises has done CNC machining, component design, R&D. We design components for air systems, turbo diesels, turbochargers, fuel system components. We have a large-scale CNC machining factory here that we can machine and component design on a mass level. We also do engine calibration, powertrain calibration, transmission calibration using our load-bearing dynos behind me. The two parts of the company form one for engineering and a full encompassing design for CNC machining and turbo diesel tuning. This is the introduction to the L5P Y-Bridge for 2017 to 2026 current models. The L5P is the turbo diesel engine that is in the 2017 to 2026 models for 2500, 3500 HD models. What I have in front of me is the factory Y-Bridge. This happens to come from a 23.5 model year truck, and I'll get into why that came from that here in a second. One of the things that we do here is we look at problems in trucks. What does it hamper as far as airflow, for power, for fuel efficiency, for fuel economy? And then we take those components and then begin to design and model something that would be better and beneficial. And then the other thing that we do is decide whether or not we can mass produce it and provide value to you when we bring those components to your home and you can install them on your truck. So what I got in front of me right now, like I said, this is the 2023 L5P Y-Bridge. This would be bolted in right in front of the turbocharger on your truck. What we do when we start component designing, we have to scan to figure out when we design a new component, we have to look at what we are working with as far as points of connection, points of entry for airflow or for fuel flow or whatever we're working with. And so all these dots on here, what we use these for is to scan the Y-Bridge with our 3D scanner so we know what components we have to work around. And when we're done scanning this, we have what's called the 3D model. So in 3D space, we can begin looking at how big we can make either the chambers, how big we can make the airflow ports, how big or how expansive we can make certain components on the Y-Bridge. And that's why we scan this to begin with. And then once we get it scanned, we go into 3D model space. We use SolidWorks, Fusion 360 for design. And then once we're in design space, we 3D print a model. And then the 3D printed model inside SolidWorks shows us how much more the component would theoretically flow. So if I were to take a factory component as an example, and then I were to make it either larger, more smooth, increase certain areas of the component, SolidWorks and solid modeling will tell us exactly how much flow or how much less differential pressure there would be across the particular item. And that is kind of how the creation process starts. So from there, we continue to work on down the path of the component. So we'll go and continue to 3D print more pieces and parts. This is the final generation of the L5P Y-Bridge that we came up with. And this all breaks down apart. And the biggest component that we found on the factory Y-Bridge was this component right here, where these two pieces meet in one spot was the biggest restriction on the factory Y-Bridge. You can see here how thin that actually got in this area, how small this area actually was. We knew that was going to be a problem. The other problem with the factory Y-Bridge, on the passenger side of the motor, 70% of the airflow was delivered, which meant that the driver's side of the motor was significantly starved from airflow. So when we went into 3D space and started creating this, we made this entry point to the Y-Bridge split much larger in diameter. 3 inches is the inside, and that's up from the 2.5 that the factory was. So the volume of area through this section here dramatically increased. We're over 30% increase in area just here, which means that this side of the motor, which would be the driver's side, the volume inside this and the airflow supplied to this side, being the driver's side of the motor, is now a 50-50 balance between passenger and driver's side, which means that the motor, each side of the motor, would make the exact same amount of power because it has an equal opportunity for airflow, unlike what the factory had. And that was the biggest component. So once we're done in the 3D space, 3D print space. We move all this stuff into design space for casting and machining. So the next components that I'm going to show you are actual 3D casted components out of billet aluminum. And then if I bring these in so you guys could see them, you'll see here is exactly what the plastic components that we 3D printed looked like. So when they're finally done, you can start to see these things take full shape. So now what you see is our final product that will be available to market. And I'm just going to start out at the two pieces of the Y-Bridge. We have a off-road version of the entry to the Y-Bridge. We have two ports here, one for methanol, one for nitrous, boost reference ports, whatever you guys want to use them for. We use a Wiggins style clamp. So the clamping assembly, this would bolt in here, and then we supply you guys with a clamp. And then it's a quick release pin. You just push the pin, pull it out, and then the Wiggins assembly will come apart, and then you can clamp the component onto the Y-Bridge. This is a leak-proof seal. It's a design that people have used in the racing and automotive industry for a long time. The reason that we use a Wiggins clamp is because this component right here, the Y-Bridge section, is physically bolted to the motor. The other side of this is bolted to the intercooler or charge pipe section. These two will move ever so slightly, and under boost pressure, these two are trying to push each other apart. The Wiggins clamp, as boost pressure goes up, as load goes up, the clamping assembly on the two O-rings that are integral to this, they force the two connections to be a tighter seal, so we will not have a boost leak here. So for guys that are going to use EGR or factory component trucks, we also designed and manufactured a EGR flow system that has the factory style blending valve into it. So for guys that are 100% compliant trucks, you'll, instead of use the off-road version, you're going to bolt this into place, and then you'll put the Wiggins clamp on here. The factory Y-Bridge will bolt up in place. The EGR cooler assembly will bolt right into here. So now you can use either one of these components for off-road use or for factory emissions equipped trucks. You can bolt this in place, and then the truck will utilize EGR. So from there, we worked down. We actually knew that the 23.5 model year trucks had two map sensors in them, just like the Y-Bridge I showed you. This is your map sensor number one, and this is your T-map. So a lot of people have asked for when we do a Y-Bridge, we should put a spacer in there, and we listened to you guys. So there is a map sensor spacer on both of these, as you can see here. So map number one and your T-map, both are spaced away from the Y-Bridge. So you guys won't need to buy a map sensor spacer from anybody anymore. You'll bolt this Y-Bridge in place. That'll save you 100, 150 bucks. Bolt the map sensors in, and you are good to go. The last thing that we did for guys that are gonna run compound turbo trucks or our 69mm turbos or some of our higher performing bigger fuel system components like a Dan's Diesel 66 or our 65mm turbo, we are putting a 10 bar boost reference in here so you guys can screw our 10 bar sensors in here and then connect them up to the map sensors. So now you can measure boost pressure past 45 pounds of gauge pressure. And then lastly, there are wiring harness components that we still need to bolt in place. So the main engine wiring harness runs across here. We put two tabs in here so you could bolt the wiring harness down so nothing's moving around. And then also tabs, mounting tabs, so you could lock in the cooling lines and other wiring harness components in here so nothing's left moving around or maybe rubbing and chafing on top of this Y-Bridge. And then you'll see on the bottom, this is a full 3-inch diameter outlet which bolts into the Y-Bridge, into the pedestal from the Y-Bridge. They're much larger than the factory. We're still bounded by the pedestal size, the entry into the pedestal. But if you look inside, we are actually significantly larger if you compare it to the factory piece. Once we're completed with this design, we've showed you how it all works. We need to verify that it performs not only just on a flow bench, but on the dyno. This company is well equipped to do both of those. We use an outside source to independently verify and validate flow. We actually use two of them, SoCal Diesel and Guy Tripp. over at SoCal Diesel in California, and then the other one, some of our local partners here in Blair. So what they do is they put this Y-Bridge on the flow bench, and then they draw vacuum through the bridge so we can validate that it flows a certain amount. Then we repeat the same process with the factory component. And then we needed to verify that the EGR section would flow the exact same amount that the factory EGR component would, which is this blending valve here. So I have two blending valves. I need them to flow the same exact amount so I don't have check engine lights on customers' trucks for EGR system performance. And then after we're done with the flow bench and flow validation, we put these on the dyno. We as engineers need to isolate every single other possible scenario. So on the dyno, which we will show you, we will load the truck up with a factory Y-Bridge in place, validate over the course of 5 dyno passes exactly what the truck would make to the rear tires. And then after we're done with that, we'll bolt our Y-Bridge in place, make no other changes, relog the truck on the dyno, take an average of 5 dyno passes to show you exactly what it did or didn't gain. It's easy for us as calibrators to show exactly what these would gain. A turbo diesel would typically open up the vanes a little further for a given boost pressure and a given fuel mass. And once we know that, we can validate that the truck actually is making more power even before we look at the dyno numbers. How you would actually install one of these L5P Y-Bridges is step 1, you're gonna pull the intake out of the truck. And then step 2, you're gonna pull the wiring harness connection clips that sit on top of the Y-Bridge. You're gonna disconnect those and you're gonna remove them out of the way. And then you're gonna take the intake air horn that's currently in the truck and you're gonna disconnect it and then remove it out of the way. You're gonna go down and you're gonna remove 4 bolts on either side of the Y-Bridge, and then that'll allow you to disconnect and pull the entire Y-Bridge assembly out of the truck, assuming you have removed the throttle valve or the aftermarket charge pipe connection from the throttle valve out of the way. And that will be depending upon your truck on the components that would have been installed. Once you've got all those out of the way, then you're going to take our brand new Y-Bridge and you're going to determine whether or not you're going to use 2 map sensors or 1. For people that only have 1 map sensor in the truck, you're going to install the plug that we supply you in place. And then once you've done that, then you're going to install the entire Y-Bridge into the truck. You're going to bolt the Y-Bridge down onto the factory pedestal area. And then you're going to determine if you're going to want to use the off-road race version or the EGR supplied section. And then you're going to bolt that in place using the Wiggins clamp to lock everything in. You're going to insert your map sensor and your T-map. And for guys that have 23.5 model year trucks, you're going to install the secondary map. And then you're going to connect the bottom connection to the either aftermarket charge pipe that you're running or the factory charge pipe. Now remember that our off-road race version will just connect with a boot and clamps, which would have otherwise been included with your aftermarket charge pipe. For guys that are going to connect this to the factory components, you'll use the EGR cooler section, Y-Bridge blending valve section, and you'll bolt that into the factory charge pipe. Install time is approximately 1.5 hours. In conclusion, this is exactly what we've covered. We talked about the factory Y-Bridge, which is this 2017 to 2026 model year trucks. We are going to replace the factory Y-Bridge with a high-flow, max flow design, ported and polished casted component that allows you to connect a aftermarket EGR removing section into the Y-Bridge, or you can connect a fully emissions equipped EGR section into the Y-Bridge. We built this Y-Bridge for maximum fuel efficiency, max performance, max economy, and max power. That was why we came to market with this. This is the first to market of its kind of a full encompassing cast Y-Bridge. If you guys want any more information on this, hit us up on Instagram, YouTube, social media feeds. These are also going to be on our website. It'll be underneath our product and new product release sections. If you have any other questions about this, you can also call us at 833-789-7700.